Facts Only Test Prep.
Welcome to Facts Only Test Prep. We're called Facts Only because we give you everything you need and nothing you don't when it comes to the SAT. So please enjoy the next video.
Basic systems of equations.
Systems of equations show up throughout the SAT math section. They're in easy questions, they're in hard questions, they're given as story problems. They're also given in simple form. We have more than one video on systems of equations, so I urge you to check them all out. What I'm going to talk to you about today is the basic systems of equations and how to solve them. You start looking at this around 7th or 8th grade, depending on where you are in middle school at the time. It doesn't hurt to review elimination and substitution and just what to do with the various coefficients. And it also helps to see the forms of the questions. So we're going to tackle that today. You're going to need Test 1, Section 3, number 18. Test 1, Section 3, number 11. Test 3, Section 3, number 6. Test 4, Section 3, number 19. And Test 3, Section 4, number 30. Pause the video, go to factsonlytestprep.com, click on the links if you need those tests. And let's get started with Test 1, Section 3, number 18. This is a free response question, and we're given a system of equations here. X plus y equals negative 9, and x plus 2y equals negative 25. We could solve this with either elimination or substitution. I'm going to use elimination, which means I'm going to multiply the top by negative 2. And that's going to give me negative 2x minus 2y equals positive 18. And then I've still got x plus 2y equals negative 25. You could multiply by the positive version and subtract. I multiply by the negative and add, just because sometimes those calculations are a little bit easier once you've arrived at your final figures, at least for me. It's a matter of preference, I'd say. 18 plus negative 25 is negative 7. Negative 2y plus 2y is 0. Those cancel. That was the reason that I chose negative 2 as my elimination multiplier. And negative 2x plus x is negative x. Negative x equals negative 7, which means that x equals 7. That's what you would bubble in. And in your free response answers, you'll only have positive answers. So if you've got a negative number, really good to double check and see that in fact, oh, negative x equals negative 7. Let's make sure that x equals 7. And that's what they're asking for. Let's do another one. Here is Test 1, Section 3, number 11. Here's a story problem, but it can be solved with a very similar method as we just used. In the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively. Respectively just means in that order. It doesn't mean that you're being respectful. X weeks after July 1 during last summer. You don't need to know that it's July 1 after last summer. What was the price per pound of beef when it was equal to, very important language here, the price per pound of chicken? So what we're being asked is, when is beef equal to chicken? And because these need to be equal to each other, we can set the two terms that involve variables equal to each other. So what I'm going to write is 2.35 plus 0.25x equals 1.75 plus 0.40x. You might want to multiply both sides by 100 to get rid of the decimals. I don't think you have to. This would be the calculator section. Oh, you know what? It actually would not be the calculator section. So yeah, you might want to multiply by 100. I think we can handle this without doing so, and it'll save space on the screen. So I'm not going to do that. But that would be a way, if you're uncomfortable with decimals, to fight through that process. I'm going to subtract 1.75 from both sides. And that gives me blah, 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 0.6 plus 0.25x equals 0.40x. And then I will subtract 0.25x from both sides. And now I have 0.6 equals 0.15x. And if I divide both of these by 0.15, and here's where it actually would come in handy to multiply everything by 100, because 0.6 divided by 0.15 is the same as 60 divided by 15. And that is very simply 4. X equals 4. Here's something that is always important to do when you're taking any SAT question or when you're answering any SAT question. Answer the question they're asking. So I've just found that X equals 4, but they want to know what the price per pound of beef or chicken is when they're equal to each other. So I need to put this 4 for X back into one of these two equations. Because they're equal to each other, their answers will be the same. So I can choose which one I prefer. I'm going to put it into this top equation because I know that 0.25 times 4 equals 1. So this is 2.35 plus 1, which is 3.35, and D is your answer. Another one, this is test 3, section 3, number 6. The reason this throws a couple of students or throws students from time to time is that the coefficients make using elimination a little trickier than it was in our original question, in the first question from this lesson. So I can't just multiply the top by, I guess I could multiply the top by 2/3 or something like that, but then I might be dealing with fractional or rational coefficients. What I'm going to do is multiply the top by 2. I'm going to eliminate my y values here. I could just as easily eliminate my x values if I wanted. And I'm going to multiply the bottom by 3. The reason I've done this is that multiplying the top by 2 and the bottom by 3 is going to give me a coefficient of 6 for both of the y values. In fact, let's make this -3, and I can add instead of subtracting. My new expressions are, or my new equations are 4x minus 6y equals -28, and 9x plus 6y equals positive 18. Notice again here that I want my coefficients to be the same. Oh, that's an ugly circle. Let's try that again. I want my coefficients to be the same and their signs to be different. That's the purpose behind elimination. So those terms cancel, and then 4x, that should be -9x, -3 times +3, -9x. 4x plus -9x is -5x. -28 plus 18 is -10. But when I divide both sides by -5, that's where I get x equals 2. And you can see, even as I'm discussing this, positives, negatives, it's very easy to let them slip away from you. Pay very close attention to your signs when you're doing systems of equations. I know that x equals 2. Again, answer the question they're asking. They want to know what x minus y equals. So now I need to put this 2 back into one of the original equations and solve for y. So, let's use this lower equation. It looks like it's dealing with a smaller constant on the right-hand side of the equation. I like that. So when x equals 2, we get 3 times 2 minus 2y equals negative 6, which means that 6 minus 2y equals negative 6. Subtract 6. Subtract 6. I'm going to move up a little and change colors. Negative 2y, that's an ugly y, negative 2y equals negative 12. Divide both sides by negative 2. And y equals positive 6. Negative divided by a negative. All right, so I know that my x equals 2. My y equals 6. X minus y is 2 minus 6, which is negative 4. That's why C is your answer. Another one. Let's just keep doing these until they make, until they feel like second nature. This is test 4, section 3, number 19. This one's showing up pretty late. There are a couple different ways to do this. This one lends itself very nicely to elimination. So let's multiply the top by 2 on both sides. And notice that I'm going to get that nice negative 6 as my x coefficient. Whenever I'm doing elimination, I'm just trying to use the variable and coefficient that will eliminate the most easily. You can choose x or y. I'm going to have negative 6x plus 8y equals 40, and 6x plus 3y equals 15. My x's will cancel. 8x plus 3y is 11. I'm sorry, 8y plus 3y is 11y. And 40 plus 15 is 55. I'm going to divide both sides by 11. Y equals 5. Now this is a free response answer. It's very tempting to just want to bubble in 5, but they're not asking you for the value of y, they're asking you for the value of x. Let's put 5 in for x and see what we, let's put 5 in for y and see what we get for x. If we put, and I'm going to switch to green just so I can work in this little pocket here. 6x plus 3 times 5 equals 15. Then we say 6x plus 15 equals 15. Subtract 15 from both sides. And 15 minus 15 is 0. 6x equals 0. That means x equals 0. You should bubble in a 0 there. And you would get the same result if you had put the 5 into the top equation as well. Let's do one more. This one is very involved. I don't think it's especially difficult, especially if you're using the systems that we've discussed in these first 4 questions. This is test 3, section 4, number 30. And really just stay true to these steps. I would even argue that you should do this a couple of times or watch the video a couple of times and just build this by muscle memory. It will strengthen you in all of the earlier steps as well. In the equations above, B and C are constants. B is C minus 1/2. That means that B equals C minus 1/2. We're going to do some substituting there and limit the number of different constants or variables or just letters that we need to deal with. So which of the following is true? Let's not even worry about the answer choices yet. Let's start by substituting. 3x, and we know that C minus 1/2 is equal to B, so I'm going to rewrite this as 3x plus C minus 1/2 equals 5x minus 7. And then I know that 3y plus C equals 5y minus 7. The reason this is difficult is because there are so many moving parts. But think back to that earlier question about the chicken and the beef. The reason we were able to make them equal to each other is because at that point, chicken and beef were worth the same price. If I can make as much of the top value equal to one particular, if I can make the top equation equal to one particular value on one side of the equal sign and do the same to the bottom, then I can set those two values equal to each other. That was a lot of me talking. I think I'd rather show it to you. I see that I've got these -7s, and what I think I'm going to do is move everything in both equations to the left so that everything is equal to -7 in both equations, and then set them equal to each other. So this is 3x plus c minus 1/2 minus 5x equals -7. 3y plus c minus 5y equals -7. Okay, so if each of these expressions is equal to -7, that means that they're also equal to each other. I'm going to simplify them and then try to put my resulting simplified version in terms of x. So 3x plus c minus 1/2 minus 5x, that's the same as -2x plus c minus 1/2. 3y plus c minus 5y, that's the same as -2y plus c. And remember, these are equal to each other. They each have a positive c. I'm going to subtract c from both sides and cancel. Now I've got -2x minus 1/2 equals -2y. This isn't so bad. I'm going to add 1/2 to both sides. I'm going to work up here in the corner a little bit. I'm going to change to green too. I've got -2x equals -2y plus 1/2. If I divide both sides by -2, I get x equals positive y minus 1/2 divided by -2 is -1/4. So instead of this being positive, I'll have a negative down here. X equals y minus 1/4. X is y minus 1/4. That means A is your answer. Okay, that last one was pretty involved. I appreciate you bearing with me on that. Notice that it was question 30. That means it's the hardest on that section, and you're really scraping the ceiling for points if you're getting that right. If you're having trouble with that, focus on the first 4 questions that we did today. You'll have a really nice foundation for tackling these systems of equations, and you'll be ready to look at our other videos on systems of equations. Good luck, everybody. Hey, thanks for watching, everybody. Make sure that you like us and subscribe and hit the notification bell. That way you'll get information on the new videos as soon as they're available. It helps us a lot. Also, visit us at factsonlytestprep.com. That's where you'll find links to the tests that I use in my lessons, along with some other resources that we prepared for you. Thanks and good luck.